Assalamualaikum warahmatullahi wabarakatuh, and a very good day to both panels, Encik Hamzah bin Muhammad Dom and Encik Omar bin Asharun. I am Aqilah Zayanie binti ZAINURIN, a final year student in Bmmm with a matric number of B0717108006. Will be representing my research study about the effect on vertical depth from free surface or multiple rotor current turbine by using a simulation, and I am under the supervisor of Encik Muhammad ARIZAM bin ABDUL WAHAP. Begins with the introduction. Generally, there are four types of natural sources that have been used for generating electricity and power, which are wind turbine, steam turbine, gas turbine, and water turbine. Among these four types of sources, water has the largest scale as it covers 71% of Earth's surface. And among all types of water channel, ocean have more advantage because it has higher density energy, long-lasting supply, and easier to develop. Furthermore, the energy from ocean are generated by the tidal energy that can produce wave, which contribute to the velocity flow of water. Next, proceed to problem statement. There are two problems stated in this research study, which are: first is the depth of water flow from free surface is unsteady. Therefore, the effect of depth would be differs according to its position in water. Second is the weight and performance of turbine can be identified based from the free surface by using a simulation. Next is objective. This research consists of two objectives, which are: the first is to identify the proper distance of depth from free surface to the rotor, and second is to simulate the application of multiple rotor current turbine in a small waterway such as rivers, estuaries, lake, and others. Now moving on to the scope of research. In this research, values of depth from free surface can affect the performance and disturbance of the turbine, since the flow of water at certain depth level will be different. Apart from that, there will be a simulation conducted by using the fluid flow fluent in NC software, and the simulation parameters will be based on the research journals and the location that have been selected. For literature review, I will be explaining a little bit about the effect of vertical depth of free surface. First, there are a big difference between the wind and tidal energy as the density value itself is different. Water have a bigger density compared to the wind. And next, the close distance to free surface will cause the free surface to affect the structure of the downstream. And next, the depth variation will cause an unsteady loading to the flow of water. For methodology, as illustrated in the slide, that is the progress flow chart from stating the problem until running the simulation. For the problem statement and background research studies has been explained in the earlier slide, and for the geometry design until running the simulation will be explained in the next slide. Before designing the turbine, the details of location are required in order to represent the water channel to simulate the turbine, and the location that have been selected to be employed in the simulation are Malacca River. And as shown in the table, that is the details for Malacca River that have been obtained by a few websites. Based from the details that are shown in the table, the main data that are important to be applied in this simulation are the speed and the depth, because the depth will be used for the domain and turbine size, while the speed will be used for the setup and properties in the simulation. Now proceed to the geometry of turbine. As shown in the table in the slide, That is the list for element required when designing a turbine. The details in the tables were referred from a research journal of a numerical turbine simulation and have been modified to satisfy the size of the location that have been selected, which is the Melaka River. As illustrated in the figure above the table, that is the final look of the modified turbine that have been designed in SolidWorks, which have 3 blades and applied the airfoil same as the reference journal, which is Tian. And the figure below the table is the illustration of the airfoil that have been applied in the design turbine. The modified geometry of turbine will implement the scaling law in order to obtain the outcome result that is relevant to the selected location, which are in replacement of the different test facility used from the journal. For your information, scaling law is also known as fruit number, which describe a different flow regime of an open channel flow. Next, moving on to the distance between rotor. The distance between rotor were measured from the middle of the first rotor until the middle of the second rotor. And next, the applied distance for this design simulation is 1 times diameter, which equivalent to the 2.847 meter. And lastly, there are research that use 1.2 diameter as the distance between rotors. However, this simulation use different distance due to the different location and different size of the turbine. Next, moving on to pre-setup and properties, there are 3 main criteria that are required before running the simulation, which are domain sketching, meshing generation, and setup selection. For domain sketching, in order to get the accurate and desired position of the turbine, the domain will have to manually sketch in the geometry section in the ASCII software, and which later will be added to some operation called Boolean. The second criteria, which is the meshing generation, meshing will be generated in the mesh section in ANSYS software. There are 3 important elements in meshing setup that will change from the default, which is advanced size function, relevant center, and assembly meshing. For advanced size function, it will set to curvature in order to get better and accurate result, and for the relevant center will set to medium, and lastly the assembly meshing will set to tetrahedron. All these elements will change in order to obtain a better outcome results, because when the advanced size function is set to curvature, the meshing will be more refined compared to when the advanced size function is turned off. Now proceed to the next step before generate the result outcome, which is the setup selection. In setup selection, there are a few setup that need to be defined, which is the solver selection, which is the solver that I have selected is pressure based and transient formulation. As for the material, it is required to create an additional material, which is the water liquid, or called as H2O. It is important to create this water material as it will represent the water because the density of water and air is different. And next, the selected viscous model for this simulation is K epsilon. The setup under the viscous model default. And for the solution method, the scheme applied is simple, as this simple is the most suitable solution for this turbine simulation. Finally, before running the simulation, calculation activities criteria such as time step size were set to 0.001. The reason for 0.001 is chosen is because the smaller the value, the shorter the computational time it will be, rather than using the bigger value of time step size. And next, the number of time step is 50, while the max iteration is 20. Next, proceed to comparison between reference journal and current study. As shown in the table in slide, that is the comparison between the reference journal and the current study. The test facility used were different, which caused the diameter of the turbine change from 1.2 meter to 2.847 meter. Moving on to the result and discussion. Based from the figure shown below, it is the converged solution from the center position turbine simulation. And for your information, in transient formulation, it is considered converged when the residual reach to 10 the power of -6. Other than that, when there were no changes up to 300 iteration, it is considered converged. In this discussion, there will be a little explanation between two positions, which are the center position and the upper position. Besides that, the related parameter of generated outcome results were velocity and pressure. After running the simulation, there were two outcome results that were generated from the result section in NC software. First is contour and second is streamline. Based from the figure in the slide on the left side, that is the velocity contour for both position, which is center and upper. We can see that the pattern for both position is the same, but that is not the case for the pressure contour, as the position is different, so the pressure becomes different. For the streamline, velocity streamline of center position and upper position, not not much difference. We can see there is not much difference between the center position and upper position. Lastly, to be concluded, the approach of redesigning the turbine using SolidWorks and the simulation using NC software satisfied the objective of simulate the application of multiple rotor current turbine by using NC software, and the other one is to identify the proper distance of depth from free surface to the rotor. That's all from me. Thank you.